Okay, good evening. My name is Johann Nishant. It's Johann, by the way, and it's a very, I don't know, it's very confusing, I think. I've not come across another person with this very weird combination of names. But yeah, that's how it's pronounced, Johann, apparently. So, before we begin, let me tell you a bit about myself. I have a dog. He's 4.5 years old. These are my passions in life. I like traveling a lot, and while traveling, I like eating different things in different places. And for the last 4 years, I've been really falling in love with this incredible field of astronomy, astrophotography, and even slowly a bit of physics thanks to ABAA and astrophysics in general.
Need one light.
So how did it all start for me?
Need one light because
in 2012, I was on the internet a lot. Like I'm sure all of you love to go on the internet too.
You can't record.
And I saw a similar photo like this. Before I go ahead, any photo with a clear big watermark is taken by that respective photographer. Everything else is taken by me. So I saw a photo like this in 2012. And I had absolutely no idea of anything about astronomy, but I had a decent idea of photography back then. And I immediately thought this was taken by Hubble or some giant observatory or something like that. But once I read the article, I realized it was taken by an amateur astrophotographer. I was shocked. I was really shocked. I thought, how was this possible? I thought it was fake. I was really looking up into it and reading up how do you get something like this? So thus began my journey. And about 2 years, I was trying to save up cash to get a telescope and reading up a lot about this hobby. This is a giant hobby to start with, something like that. I was quite stunned actually. So in 2012, I thought, why not? I had a DSLR, I had a normal kit lens and a wobbly tripod. I just went to my balcony, pointed in a very random direction. I think it was near the Milky Way now, when I think about the Sagittarius of the Milky Way. So I pointed it and I just took a random exposure. So to you, what does this seem like? It looks like gibberish, And but technically, that's a globular cluster. It's a Messier 22. It's a globular cluster. I had no idea. I thought it's some dust in my. I thought it's dust in my camera. But then I had a really good forum I could get back to. It was a forum in Reddit, and they really guided me in the first few steps to get into astrophotography. So, what is astrophotography? Technically, photographing anything in the sky, astronomical objects, is astrophotography. It's not only the night sky. We even do solar astrophotography. I'm sure some of you here are experts in that as well. So, astrophotography has a rich and long history. It's been around for quite some time. I believe the first photo was 1840. And auspiciously, even today, I think Hari shared in the group, this is on July 17th was the first photo of Vega was taken. And Vega is technically a deep sky photo, so it's very auspicious that I'm giving a talk on deep sky astrophotography today. And this photo really catches my eye. Can any of you name this nebula? Or not people know it. Yeah, that doesn't make sense. But okay, so this is the Orion Nebula, taken in 1883 by someone called Andre. I don't want to go to pronouncing the last names. Good. So when I got into this hobby, this was what I thought astrophotography was. I thought it was marketed and meant only for scientists, for research people doing degrees or something like that. And this is a meat ad, by the way, in the 70s or 80s. But then I slowly, when I got into this hobby, I realized it's something you can do with your dog, with your friends, with your family. It's something you can enjoy. You can have a fantastic time, visit new places, enjoy yourself, find something completely new and different. And this is that kind of hobby, at least for me. And I really like the way Prakash sir described astrophotography, but this is how I would describe astrophotography. It's a good division between art, science, and technology. It's definitely an art form, so if you're an artist here, this is the way to go for you. So, because why is it an art form? We use a lot of non-scientific and aesthetic methods to bring out the photos. So we get scientific data, but we use aesthetic methods to bring it out. So what we finally produce cannot be, you can use it as scientific data sometimes, but also sometimes it's more of pretty pictures, like I would say Ravi sir used to call it. And it's a science because you need a good knowledge of science. If you don't have one, completely fine, you can learn. I didn't have a decent knowledge of science at all, and you can learn so much in the internet. So science, as in you need a good knowledge of weather. I think that is the most painful thing I would say. And weights and civil engineering, a lot of things come into play when you look at astrophotography. And taking a photo is finally only 60% of the work. The rest is, I would say, processing the photos. So you also need a good knowledge of computers and software. And if you have all this, and if you don't have all this, don't worry, you can easily pick it up anytime. And before we go ahead, I thought we should know these three concepts properly. I'm sure some of you already do, but just for the beginners, I thought I should talk about these three concepts. The first is aperture. So aperture basically is the diameter in millimeters of the objective lens or the mirror in a telescope or a lens or anything like that. But it controls two important things. The first thing is the light gathering power. Imagine aperture of your lens or camera or your telescope as a giant bucket. The bigger the bucket, more photons of light of the astronomical object you can take. So if you want to get brighter objects quick, you need a bigger aperture telescope. And second thing is resolving power. So bigger the aperture, better you can resolve tiny details in fainter things in the sky. So these two things, I would love to go a little bit more deeper, but just because it takes a very long time, so I thought of cutting it a little short here and there. So here's a photo by a very famous astrophotographer. His name is Damien Beach, and it's a simulation technique. So it's a simulation of how aperture size affects the resolving power of an object. How much you can resolve with the aperture size. So the first photo is taken with simulated to take with the 4-inch telescope. The next with the 6-inch, 8-inch, 10-inch, 12-inch, 16-inch. If you actually look at the tiny details around Saturn in each of the places, you can see that as you increase the aperture size, the resolving details get much better and better. You can resolve tiny things. If you look at the 16-inch photo, I would say that comes close to Hubble. That looks very nice, at least to me. So the second thing is focal length. And focal length determines the angle of view. To make it simple, focal length is the zoom amount. It's very simple. It's actually wrong to say that, but to understand it, focal length is basically how much zoom your instrument is capable of. So imagine this. I'm sure all of you, if you haven't seen it, go out, not now, probably next year, and go out and look at this. This is the Milky Way. This Sagittarius is the Milky Way. But I'm not interested in the Milky Way. I'm interested in this object right here. Can any of you name that object? Mars, yeah. So that's Mars. So this is Mars shot at 24 mm focal length. Focal length is measured in millimeters. Okay, this is 24 mm. So this is Mars again, shot at 105 millimeters. This is a stacked and processed image. I shot this in Yeligiri, by the way. And this is Mars taken at 2000 millimeters. 1000 millimeters with a multiplier. We'll talk about that later. So, but the thing which I want you to know is there are 3 focal lengths used. This is 24 millimeters, this is 105 millimeters, and this is 2000 millimeters. So can you understand what millimeter does? Focal length does. So focal length is extremely important when you want to decide what instrument you want to buy, because it really determines what kind of objects you can image later on. So if you buy a telescope like this, you will not be able to image some of the larger objects in the sky, because this is already 1000 mm sitting in 1000. The next topic I want to talk about is focal ratio. Focal ratio is a very simple relation. It's basically focal length divided by the aperture. As simple as that. You get a number, a constant number like this. 2.8, 4, 5, 6, 8, 10. If you did photography, you should get this. Should seem a little similar to you. So, in basic terms, if you have a smaller number like 2.8, 4, and 5, these are called fast telescopes. You can get your images very fast because they tend to be more brighter. I would love to go a little bit more deeper in this, but probably the second or third part we can talk a little bit more deeper into that. So if you want images quick and fast, you don't have, your tracking mount is not very good and things like that, you would look at a fast telescope, 2.8, 4, and 5. And if you want a very long focal length, because when this number increases, the focal length also increases. So when you want to image tiny objects, you will be looking at a larger f ratio, and also you will require a longer exposure to achieve the same amount of brightness. We'll be talking about this a little later, the second and third parts. Before we go ahead, let's talk about the types of astrophotography. And again, because there were a lot of new beginners here, I thought we should do this before we actually delve into deep sky astrophotography. So the types of astrophotography. The first type, which is very interesting, is solar system and planetary astrophotography. There are plenty of people here, Santosh, Prakash, Satya, who love to do and actively pursue this kind of astrophotography. So this was taken by Santosh right here. This is of the H-alpha image of the sun, and that's Mercury, right? That's Mercury transiting the sun. So this is an example of a solar system astrophotography. Basically, anything within the solar system is generally termed as solar system or planetary astrophotography. And again, these are very broad categories made by people like amateur astrophotographers. So it's not strict to be calling something solar system, deep sky, and things like that. It's all, you can decide what you want to call it. The next thing is, again, a beta solar filter image of a sunspot taken by Prakash sir. And again, this is an example of solar system astrophotography. This is Saturn, imaged from Bangalore itself in HL. This is Mars, still a very, not a very good image, I would say, but I'm still working on that. And the other images you can do, which I believe is kind of conflicting for me, is comets. So the way we image comets is a little bit similar to deep sky images, not planetary images. So this is comet Lovejoy, which visited us in 2014, January 2014, and 2015, sorry. And it was a fantastic sight to see and image, and it was my first and only really good image of a comet, I would say. And the next step of astrophotography is wide field astrophotography. This is, I would say, is one of the easiest, but also very challenging types of astrophotography if you take it very professionally, if you take it very seriously, not professionally. So you can do photos like this. This is a photo of my cousin. I took this not 2 weeks back in Tirunelveli, Tamil Nadu. And you can see the Sagittariusm right over him, and I didn't have a tripod on it. I just kept my camera on a water bottle and took this image. Very simple, very easy to do. You just need a long shutter speed and a somewhat stable background. I mean, a mount or whatever thing you want to keep your camera on. So you can do different kind of shots with this. Framing here is more of an art. You have to really frame your object correctly. You have to compose your object correctly. And there's not a lot of technicalities. The processing is kind of simple, and you can get really interesting shots like this. So this was taken in Kemal. I hope I'm pronouncing that correctly. Okay, is that correct? Yeah, Kemal. So I love this place. It's really my favorite place. I've been here for 2 years, March and April 2 years back. And I mean, every year I want to go to this fantastic place because it's so dark and you get really, really good shots in this place. So that's a meteor streaking across the sky, by the way. And very simple, very easy shot. You can take it up to a next level if you add tracking into the mix. So if you get a tracked shot, you use a mount or some kind of tracking motor or something like that, you can get a more detailed shot. It's a single shot again. So you can see much more of the dust lanes, and you get a much more, this is a 1/22nd exposure, by the way. And if you take it to a next level, you can track your shots and you can also stack your shots. I explained what these two terms mean at the end of the session, but you will get more details and you will get very less noise in the images if you do this process. Another type of wide field astrophotography is star trails. Very easy to do. I mean, it takes a lot of time, but it's just you put your camera on a tripod and you keep it there. And you take 30-second exposures for a long period of time, and you put it into a software and automatically get shots like this. It's very easy to do, but you have to stand out in that place for a long period of time. Maybe it's a cold place and maybe the environment is kind of harsh. The next type of astrophotography is one which I like the most and which I've been looking the most. It's deep sky astrophotography. And you get shots like this. The screen is a little, I think, here. Oh, I'm so sorry.
Maybe it's tough for you as well.
Yeah, is this okay?
Yeah.
Should I move the telescope?
Probably.
No. Okay. So the screen the colors are a little bit off from what I see here, but this is basically dumbbell nebula. It's a nebula, and M27 is the Bezier number. So in deep sky astrophotography, you're imaging objects which are usually outside the solar system. The distances are very, very large and the sizes are very, very large. Until today, I can't comprehend the distance and size. It just numbers to me so far. And it's my goal to try to comprehend how big the space, the universe usually is.
Nobody can.
Yeah.
Nobody on Earth can. So
Correct, yeah. But we should, somehow try to convince everyone to show that maybe things on Earth don't really matter. We look at how big space is. Okay, so this is Trifid Nebula, a nebula very close to the center of our galaxy, the side of our center of our galaxy. And this was taken in Yeligiri. Again, Yeligiri is a really nice place because it's quite close by, and whenever it's cloudy here and there, that place is always kind of clear for me. So I go there very often to do this. So this is again nebula, and a lot of different colors as you can see in this photo. This is the California nebula. It's actually a zoomed in version because my telescope it's already quite zoomed in. But if you actually look at it with a bit more wide angle view, it actually looks like the US state of California. And this is the Triangulum galaxy, a very, very challenging deep sky object which you can see visually. This is, I would say, Ravi sir said this was a test to see how good a sky is a Triangulum galaxy. And yeah, it's very close to Andromeda galaxy.
Why is it challenging? What tell us that?
It has a very low surface brightness. So it's not a very distinct object in the sky like how Andromeda galaxy is with a very bright core, but it has a very low surface brightness. So good question. So the next is the Sombrero galaxy. Again, I'll show you all these photos maybe later with my screen or some other screen because these don't, like when you have this white area, this is technically your photo is blown out. So it looks a little bit different from here to there. So I'll show you maybe sometime later. You can check out on my site. A little different. It's more different. And this is, I'm sure most of you can recognize this, has a very rich history and is Pleiades open star cluster, also known as Kritika, I think in Indian constellation world. And this is the Orion Nebula. I think we should, if you look at it in a different screen. Okay. The next is, can any of you guess what this is?
M13.
Huh?
M13.
No. Omega Centauri, yes. A phenomenal object to image and more actually I would say to look at. This is an object, if you look through the binoculars at telescope, it just screams at you with I think 1 million stars looking at you. A phenomenal object to image again. Next is
What is it and where is it?
It is in the constellation of Centaurus. And I would say, I don't think it's very visible now, maybe because of monsoon and it's already past its time, I would say. It's near Alpha Centauri, little above Alpha Centauri. So the next object I would like to talk about is not a very pretty picture. What do you think this is? Like to any normal, like a layman, I would say this looks like a bunch of stars, like some random bunch of stars. But to me, I would say this is my most profound image I've taken, at least for me. It still gives me goosebumps when I think about this image. So, can any of you guess? I mean, the people who already know, I think, will easily guess this. Okay, but let me just give this to you. So, this object you see here, can you see this object? That is not a common star. Technically, it's a black hole which is taking in a lot of solar masses and beaming out radiation along one direction. And we are seeing that in that direction. That is basically a quasar, quasar 3C273, in the direction of Virgo. And it's the coolest part about this object is it's 2.4 billion light years away. And you can get it with a mirror which is 8 inches. It blows my mind, you know, I still can't comprehend that. And it's 2.4 billion light years away. And it's the first time I actually used redshift to measure the distance. I could see that. I was so shocked, like redshift. It sounds so scientific, you know. And but the one more cool thing about this object is, if this object was taken and brought to where some of the stars in the sky were, it would be brighter than the sun. It's so incredibly bright, one of the brightest objects in the universe, and you can do so much with just this mirror. It's really, really fascinating. So space is really big, and especially deep sky astrophotography. And we use this term, light years, to describe distances and sizes in deep sky astrophotography. So basically, the distance light travels in 1 year is light year. Okay. And I don't know if many people know this, but objects in space appear very, very big in the sky. So an example is Andromeda galaxy. But I don't know whether you guys know this, but it's as big, it appears as big as 6 full moons. I'm sure all of you have seen a full moon. I'm sure all of you, some of you have tried to image a full moon. But can you imagine it's as big as 6 full moons? So shouldn't it be really easy to image, right? That should be your thought. But the thing is, it's incredibly dim. That is the only reason we can't see it like this. It's just an illustrative image, it doesn't indicate anything, it just shows the size difference. So if Andromeda was as bright as the moon, we would be seeing it something like this in the sky. So these objects are really, really big. It's just that they are really, really dim. That is the only problem. So when something is very dim, how do we image them? what do we do? So we have our cameras, and one method of imaging these kind of objects is using a long exposure. But one problem happens. The Earth is constantly rotating. Actually, everything is constantly moving somewhere, but the Earth is revolving quite fast, rotating quite fast. And I'll show you a small video on that. So, one of my friends called Jeff, his name is Jeffrey, he shot this video of my same telescope. The telescope is shooting a planetary nebula in Gemini at this time. And if you can see, it appears that something is moving and something, okay, even the mount is moving. So technically this shows the rotation of the Earth. Okay, and if you want a long exposure photograph, you should make sure that whatever you see in your view detector should not change. If it changes, you're going to see trailing like the star trails you see there. So what must we do to avoid that? We employ something like this, a star tracking mount. We'll look into that a little bit later. So let's look at the equipment needed for deep sky astrophotography. I'm so sorry, can you see now?
Yeah,
Is it fine?
It's
Fine? Okay. So the first important part of a deep sky astrophotography kit is a telescope. I hope till now I was making a bit of sense, and if there are any questions or anything, please save it to the end. I would love to answer them. Yeah. Okay. So you have a.
Just check if somebody is short of breath.
Oh, okay. Yeah. I'm sorry if it was too long or something. Okay. So this is.
So which means you can give a pass. That's what I think Prakash is saying.
Okay.
You can give a pass, maybe a little pass.
This demo will allow you to pause for some time.
Okay. So this is an equatorial mount, and which kind of telescope is this? Reflector, return reflector. Okay. So this is a computerized go-to equatorial mount. So once what?
You could bump it to the wall.
No. Should be fine. Okay. So one thing about equatorial mounts is that there are two main axes. There is the equatorial axis and there is the declination axis. Okay. So this is the equatorial axis. This one, the one I'm moving now, rotating it around the equatorial axis. And the other axis is the declination axis. So with these two axes, we can literally locate every object in the sky. And if we align this equatorial axis and we make that parallel to the rotation of the Earth, the rotation axis of the Earth, we technically, and if we move this along this side, the equatorial, rotated around the equatorial axis, we are moving along with the Earth. So to make myself clear again, when we align the equatorial axis and we make it parallel to the rotation axis of the Earth, and we move it around the equatorial axis, we are moving with the Earth. We are rotating with the Earth. So if one object, we point it at that object, it will remain in that field of view for how much ever time you want, until it probably hits this mount, hits this side. And if we motorize the equatorial axis with a motor, and we set that speed to 23 hours, one rotation in 23 hours and 56 minutes, and that will be the speed of the Earth, the rotation speed of the Earth. So that's basically how an equatorial mount works. And this is called a German equatorial mount because it has a T design where it is. It looks like a T from one side. And one thing with equatorial mounts, German equatorial mounts, is that they have to be properly balanced because you do not want to strain the motor. Any imbalance can really, mess up your photos and you'll start to see trailing in one direction and things like that. So for an equatorial mount, okay, I'll get to that later. So this is basically an equatorial mount, and why is it computerized? Is once it's fully aligned, once it's perfectly aligned to the pole star and the non-celestial pole, and you set it to track an object, you can literally slew automatically to any object you want. But again, a lot of alignments have to be done, and you really have to be precise that it's actually pointing there for the first couple of times. So you have to check the first couple of times whether is this object actually pointing at that object. So you will need a good idea of the sky also before using this mode. Okay, so that's basically this mode. I'll just show you how it slews if you want. So it's kind of slow, but it's going to be clear. is how it moves. In the night, if you're in the middle of a dark sky, it's really a terrifying sound, especially if it's animals alone. So yeah, that's basically how it moves and that's how it works. You will not see the motion very easily, only after a lot of time, like the time lapse, you can see the motion, how it's moving slowly when it's actually tracking an object. Yeah. Yeah. So without an equatorial mount, without a properly aligned equatorial mount, you are going to see frames like this. There's a center dot on the primary mirror, which we can use with the collimator. It's actually a little bit a long process, and I think we should cover it with a little more detail, and we should show it when we do that. So probably in the second or third part, I can cover that more in a more detailed way. Any other questions? Anything what we did so far? Anything you didn't understand? You think I can explain better?
What's the range of the declination axis?
What are-
What's the limit of the declination
It
axis?
can go all around, 0 to 90 degrees, but it can go, like, you can rotate it from, it's 0 to 90, 0 to 90 from the other side. So the two sides of the meridian. So you can, with these two axes, you can see any point in the sky. There is no point in the sky you can't see with these two axes.
What is the power source for this?
Very interesting question. So usually when I'm in the field, I take a 150 ampere battery with me. Very heavy, very painful, but always take a friend with you. They're like how my two friends who joined me today, thank you so much for helping me doing all this here. So when you take a friend or someone with you, they can help you carry this.
Remain friends?
Yeah. They enjoy the night sky and do that. So it's, I use that, many people use DC, but I prefer AC, all AC, alternating current, because the mount is actually suited for DC, but I prefer an AC adapter. My camera charging is AC adapter, laptop charging, mobile charging, everything AC adapter. So I stick with AC. Not a lot of people do this. People carry smaller batteries, and something I should look to.
You can also make to it. Anyway, you are traveling the car.
Yes.
You use your car
Yes,
battery
yes,
as
yes.
a source, but keep the engine on.
Yeah,
For some fun.
that is also you can do. Most of this comes with a cigarette adapter for cars. They come with that by default actually. So you can use that also to power your mount. And but recently, because of my new camera, that even 150 ampere is actually not enough because the cooling takes that much of. I think I'll get into that a little bit more. Any other questions?
One more.
Yes.
You mentioned about this axis
Yes.
matching the speed of rotation.
Yes.
Now, does it matter what you're shooting in the sky? Because I don't know, different objects have different.
Most of objects, like deep sky objects, planets, all move. We can track them with the same speed. Only the sun and the moon have a different speed compared to the normal sidereal rate. So apart from the sun and the moon, everything else is the same. They go at the same speed. Up here we go the same speed.
So, like, do you need to know what you're shooting and then adjust the speed according to that?
No. So you will not shoot the sun or a moon in the middle. Very rarely you go to dark sky and shoot sun and the moon. So your speed will automatically mostly be set at sidereal itself. So you would not go to that speed very often. Anything else?
How expensive?
Yeah. Huh?
How expensive?
That's inevitable, that question. So it's 1.3 lakhs, but I consider this my best investment. Like investing in stocks, I think this is the best thing for me at least, because it's really taught me something very unique and something phenomenal. So I think this is a good investment for everyone to look into.
You better tell that 1.3 lakhs is only for the mount.
Mount. This is the telescope is 30K, the 33K. Telescope is actually cheaper compared to the
Minus the camera.
Yes, minus the camera.
Actually, really you can't compare with stocks because there are some of the returns on stocks.
Correct.
There are no material returns.
Yes, material returns. Yes.
And you have to add minus the laptop, minus the software cost.
Petrol, everything.
Your two friends which you lost the battery.
Yeah. So, but it's a worthwhile investment, I would say. And it's not necessary you can distribute with this kind of equipment. You can start small. Even with a 15, I will get into that little later at the end of my talk. Even with, I would say, a 20,000 or even 15,000 investment, you can do a good bit of deep sky photography. Even with whatever you have at home, I'll explain that at the end of the talk. Okay, any other doubts?
You mentioned there's one favorite photograph of yours.
Yes.
The one which brings the red ship.
Yes, yes.
You call it a black hole?
It's a quasar. It's a quasar.
It's not a black hole.
It's an image of a black hole sucking a lot of solar masses and pumping out the radiation in one direction. Is that correct?
It's a galaxy.
It's a, yeah. I think a physics student can explain that much better. Basically, it's a black hole which sucks in a lot of solar masses of the nearby galaxy and ejects this as a beam of radiation in one direction.
Okay, it sucks, okay, fine, I understand.
Yes.
And it's not supposed to let out anything. The speed of light is lesser than the.
Yes, yes. I would not actually, to be honest, I don't want to go into relativity and things like that. That is something you talk, another time you come to a one talk. But from what I read about the object, it's apparently a black hole. And I would love to talk about it more, but I think my physics knowledge ends there, you know. But yeah, but I would love to learn about it. So maybe we can talk about it after the talk and maybe get together some Santosh.
So the rest of the specs on that photograph are galaxies, is it?
Which one? No, all stars. Yeah. Yes.
How do you control your ISO?
Yeah, so ISO is basically the sensitivity. I'll talk about noise reduction at the end. ISO is the sensitivity, and I set it to 1600. I think for my camera, 5D, it's acceptable ISO. So if you're using any other camera, make sure you set it to what you feel won't be too noisy. Optimal, yeah. So if you tell your camera, you can probably suggest an ISO or something like that.
I use a 550.
Okay, yeah. So even 800 or something like that should be fine.
So when you go on field, so
Yes.
you pick an object before and
Yes, I'll talk about that at length. I have that whole list planned out. Yeah. Is it? Yeah. Okay. So the next topic we'll talk about is the size of the sensor. And I believe this is very, very important to astrophotography because the size of the sensor determines basically the angle of view. In simpler terms, if you have a smaller sensor size, such as a webcam or a tiny portable digital camera, you can literally see a smaller angle of view. That appears like you're zooming in further. That gives that sensation. When you start the stacking process, each light frame has to be calibrated. So we do something called dark sub. This is a very highly automated process. So we take a light frame, software takes the light frame, and it takes your dark frame. Image subtracts your dark signal from the light frame. And it takes the bias frame, image subtracts the bias noise, the read noise from your light frame. And it finally takes the field illuminated, the flat frame, and divides your light frame from the flat frame. So finally you have an image free from the thermal noise, free from the read noise, and free from uneven illumination.
So the read noise is coming out of the bias frame, yes?
Yes.
And how do you do the bias frame? Just take a shot.
You take a shot with the fastest shutter speed. Basically, you're taking a shot without any signal and without any thermal noise. Thermal noise is only caused based on shutter speed, how long your shutter speed is, and the ambient temperature.
But if my camera was running for a while?
Yes. It's very, very, 1/8000th of a second will not make a difference on how long your camera is running on.
So let's say my camera was on for an hour or whatever, I've been using it. Still doesn't matter.
R is technically not, in astrophotography it's on all night, and we take darks bias at the end of the night. So it will not affect 1/8000th of a second. It only depends on how long your shutter speed is in that frame for the noise to come out.
And in that case, it doesn't really matter whether you have the lens covered or not.
If you're pointing it at the sun, 1/8000 will still cause some kind of photos. So to avoid, be absolutely sure, to avoid zero chance of any signal coming into your frame, you would make sure you cover your lens cap.
For bias as well.
Bias as well. Anything else?
How do you take the practice and cover it?
Yes, so you take a white t-shirt or this is a telescope, but you can use a camera lens as well. So when you're doing those kind of shots. So you take a white t-shirt or a white vest or anything, and you put it over this. And you use a thread, which I normally keep, and I tie it as tightly as possible without any folds. So then you put a white light source. You can use a laptop, best thing I've seen so far. Laptop with a white notepad open or Safari open, whichever browser you have open here. And so and maximum brightness. So that's a kind of an illuminated brightness working well, even with such a big opening is working quite well. So you get a very illuminated field. So set your camera on AV, or it's actually there are a lot more specifics involved, but this was a very general talk. So I would love to go a little more deeper and talk to you about how to expose for a flat more seriously, but it's a little more complex, and maybe in the subsequent parts we can take it up more seriously. But for just now, make sure it's correctly illuminated. It should be white, like majority of the frame.
You do it at the same time after you finish your photography in the night?
Yes, one important thing you should look for in a flat, there should no change in the camera angle. So you can actually mess up a lot of frames if you accidentally do this. So very big, good question.
Also one more thing.
Yeah.
You spoke about the exposure time for the camera on a fixed tripod.
Yes.
So would you be later on giving a comparison on camera on a tracked, subsequent? I didn't quite understand.
Because
You spoke about the rule of 600.
Yes. The rule of 600 is not there.
Right.
Yeah.
Exactly.
Yes.
Exactly. Will you give a comparison later on?
Yes. Yeah, we can do that. Yeah. Anything else? Any questions? Yes.
How long do you pull your telescope?
Yes. This is a very important question, and for me, ideally, when I immediately look, so why he brought up, why this question is even asked for astrophotography is, if you use a Newtonian telescope, there is air inside temperature can be different from the outside temperature. The telescope optics can be a different temperature, and the outside temperature can be different. This can lead to air currents and airy disks being produced around stars. So ideally 2 to 3 hours. So when you start, because when you bring out a telescope from the car, it's around 4 o'clock when you reach the place, ideally. And when you start imaging, it's usually around, for me it's 8:39, because alignment takes a long process. So you have a good amount of time for that to stabilize.
This has
No fan. But yeah, there are fans also provided in higher end telescopes for cooling it to temperature. Anything else? Yes.
Why do you actually wear the 600?
It's just an approximate formula. Why do you use the value 600? It is a formula for you to use. It's approximate. It's not. There is no scientific relation to why.
Empirical.
The correct word is empirical. Yeah. It's something to help you remember why the field very quickly. The actual reason is why the trailing happens. There are so many other factors you should look at. Technically, even where the object is located. If the object is located closer to the meridian, it changes, and closer to the
Just to act as probably instead of sitting and dividing it manually, Arun has developed a pinpoint stars.
Yeah.
There's an app called Pinpoint Stars. It uses one of these rules, and you just have to plug in your camera numbers, focal length, camera model, and all that. It will tell you how many seconds before trailing.
Yeah.
One use mask focus.
What?
Focus.
Yes.
Use the mask.
No. So I use something called full width half maximum. It's an algorithm which is in your acquisition software, the software you use to take images. That's an added benefit of using DSLRs. DSLRs have live view, so you can actually see what you're imaging. So once full width half maximum basically is an algorithm which tells you if the contrast in the center of the star is at maximum. Once it's at maximum, the number is usually the least. So once it's the least, that means you're very in focus. This is a method which I found which is useful, but I think a more accurate method is the background mask.
Which capture software you use?
I use APT. Yes. Anything else? Yeah. Anything else?
So that for planetary photography, we can use webcam.
Yes.
Mobile cameras are more better than
Yes,
right?
but mobile camera has a lens in front. Webcams, you're supposed to remove everything. I should have got my webcam. It's just a piece of like a chip with things like that. No.
QHY.
Yes. Yeah. This also. Yeah. So. Okay, we need a torch or something to see. The webcam is very tiny and there's no lens in front. So that's why we can't use a phone. If you are willing to remove the lens of your phone, you'll be set. You can actually, that's a good idea. Good idea. Maybe you should try that. That's a good idea. Yes.
You told me about rule 600.
Yes.
You forgot 500.
Yeah. So why people say 500 is to get a more tighter measurement. So 600, it's you're pushing it.
Like if there's any difference between 500 and 600?
Yeah. So with the 500, you'll definitely you'll be sure that you'll not get even the slightest bit of difference.
So you
Yeah.
can go with 550.
Okay, up to you. It's an approximation. It's an approximation. Technically, you can even see the shutter speed, test it out manually. Best is experience. Nothing compares to here.
For 600, what must be the ISO?
Anything. ISO, set it as much as you can so that it's not incredibly noisy, but it's also you're getting a good bit of the subject also, whatever you should be there.
Any precautions while traveling with the telescope?
Yeah, I take a lot of precaution. I actually still maintain the box which I had. I keep it in, I put 2 or 3 t-shirts and cloths and towels around it to protect only the telescope. And my mount has this white, like a foam thing you put it. It comes with the telescope.
Original packaging.
Original packaging, yeah. I should get a box. I've been pushing, delaying it for a long time.
Rest it on few bean bags.
Yes.
That's great.
But it depends on how much you care about it. Like if you even if you're paranoid like me, then you should. I mean, even though it may be safe to use a bean bag, for me I'm very I try to keep it in that original this thing to match. But bean bag should be perfectly fine too.
There is any pixel thing like that? 500, 600? Or anything will be okay?
No pixel. No pixel. But I can exactly get your question.
Like I have seen
Yeah.
8.5 some pixels for 500, rule 500.
I didn't understand that. He's a good friend of mine there.
Something else.
Okay, it's fine.
We'll show you later.
Yeah.
Any more questions, please?
Is that a dedicated astronomy?
Yeah, no. This is a DSLR which has been modified for astrophotography use. So in a way, it's dedicated because if you use it for terrestrial normal photography, the color is off balance, because it lets in IR light in right now. So your photos appear reddish rather than normal how it's supposed to be.
I think in the US you do get a Canon 60D or something.
Yeah, there are 2, even the photos which I used here, that's the 2 DSLR photos I showed. There was a 60DA and the D810A, the Nikon D810A and the Canon 60D. Yeah, astronomy. So they do not incorporate this filter inbuilt to their camera. But again, you're paying a giant amount of money for a normal DSLR, which you're paying extra actually. So
you go to the top.
Yeah.
It's not that difficult.
Okay. Yeah, correct. Yes, exactly.
So about the camera battery?
Yes.
The battery.
Okay, so ideally your camera will get, depends on your camera, but around 200 exposures, something like that, you will get from your camera. So with this one, I use AC adapter, so it does not have a battery slot. So they modified it's just an AC adapter. And because of the cooler, it's taking a lot of power. I should really find some better source. I don't know how to go above 150 ampere hours.
How much does it draw?
I think around 10 amps, yeah. 9, 10 amps.
It's like 10 times.
Yeah, no. Mount is 5 amps.
No, but mount draws 1.8.
Okay, yeah. 1.825, okay. It's my 150 ampere hour battery got over in 14 hours, over 2 nights.
I think a small Honda junk, petrol junk.
That's a good idea.
But then it'll spoil the serenity of
Oh,
the
sound,
sky. Yeah, correct. But that should be. I don't know how CCD photographers use that. I think even CCD, the dedicated astronomy cameras also have very powerful cooling.
Yeah, but it draws a lot of less current.
Okay,
2 amps.
they're optimized for drawing the current. Yeah. This is again a modification. It's a 5D.
Wait another 10 or 15 years we can take a Tesla.
Correct.
Hopefully, yes.
Okay. A round of applause to. How many of you want to do astrophotography? That's encouraging. And you feel it's interesting.